From the air we breathe to the technology we use, the oxygen family plays a vital role in our daily lives. These elements share similarities in their properties and functions, yet each has its unique characteristics that make it essential for various industries. Join me as I dive into the world of oxygen, sulfur, tellurium, polonium, and
selenium,
samelium. I'm not even going to try to figure that one out. Now, every single one of these elements are found in the Earth's crust, but I'll come back to that later. Now, all of these elements have the same amount of valence electrons at 6. Now, what are valence electrons? To put it simply, valence electrons are the electrons in the outmost part of the atom, also known as the valence shell. These electrons are the ones involved in chemical bonding and determining the element's chemical properties. Also, if you're confused, chemical bonding refers to the process by which two or more atoms join together to form a new substance with different physical and chemical properties than the individual atoms. Atoms bond together by sharing or transferring valence electrons, which is what we just talked about. When these elements become ions, which is basically a particle that is either more or fewer electrons than its parent atom, they need to have 8 electrons in their valence shell, as I referred to earlier, so they gain 2 more electrons from other atoms. When they do this, they become negatively charged ions with a -2 charge, because they now have 2 more negatively charged electrons than positively charged protons. In the oxygen family, oxygen and sulfur are nonmetals, while samelium, tellurium, and polonium are metalloids or semimetals. Nonmetals are elements that tend to have properties such as being poor conductors of heat and electricity, brittle when solid, and having low melting and boiling points. Metalloids, on the other hand, have properties that are intermediate between those of metals and nonmetals. They have characteristics of both, such as being semiconductors of electricity, having varying degrees of luster, and being ductile or brittle depending on the specific element. Now back to these materials being found in the Earth's crust. The Earth's crust is an outermost layer of the planet, and it's made up of solid rock and soil. As for the elements in the oxygen family, they are all relatively abundant in the Earth's crust, with oxygen being the most abundant element overall. Oxygen makes up about 46.6% of the Earth's crust by weight, while sulfur, selenium, tellurium, and polonium are found in much smaller amounts. Sulfur is found primarily in minerals such as gypsum and pyrite, while selenium, tellurium, and polonium are usually found in combination with other elements and materials such as copper ores or lead zinc ores. These elements are pretty well known for, you kind of need oxygen to breathe, so I think it's pretty well known. Now to finish up, I'm quickly going to share 3 fun facts about some of these elements. Sulfur has been used in cosmetics and medicine for thousands of years. Ancient Greeks and Romans used sulfur-containing compounds to treat a variety of skin conditions like acne, and sulfur was even used as an ingredient in gunpowder during the Middle Ages. Tellurium is one of the rare stable elements on Earth, and it was discovered in 1782 by Austrian scientist Franz Joseph Müller von I am not reading all that. Tellurium has unique electrical and thermal properties that make it useful in the production of certain types of solar cells, which are in solar panels. Finally, we have polonium. Polonium was named after the home country of its discoverer, Marie Curie, who was Polish. It's a highly radioactive element which was famously used to poison a former Russian spy. Despite its dangerous properties, it's also used in static eliminators and in certain types of nuclear physics research. So now you know more about the oxygen family. From oxygen to polonium, each element has its unique properties and uses. Together they play an important role in various industries and advancements in science. Also, sorry for sounding so tired. I chugged a ton of caffeine. My hands are literally spazzing right now. It is 3 in the morning, and I still have to edit the whole video. Hooray!